Hi, I'm Deepak Prabhakara, co-founder and CEO of Boxy HQ, an open source startup that is building developer tools for enterprise readiness. We help your startup get enterprise ready in just a few lines of code. And I'm here to talk to you about security and sort of my learnings of security as a software developer over the last 2 decades. And my talk is titled, All Engineers Are Security Engineers. So just a little bit of background on myself, so you get the context of who I am and where I come from. Very much a developer, a technologist. I started my career in the early 2000s, before cloud, before App Store happened. Very different days to what we have today. I had to actually go into data centers and get the hardware ready before getting started with software. And I've moved in and out of startups and worked at slightly bigger companies as well, notably Opera Software and Thomson Reuters. And most recently, before starting Boxy HQ, I was the CTO at a cybersecurity startup here in London. And over the 2 decades, I've done a lot of different types of developer roles as well. I've done a bit of front end, full stack, but predominantly my strength is back end and scaling. So just to recap what this talk is attempts to capture, I'll talk about why software security has become so important today. And we'll also talk about why security is moving closer to the development lifecycle. Developers can no longer stay away from not having to do security. And we'll talk about why that has happened. And I'll try and give you some examples of some common pitfalls in security specifically while building software. It's something us developers always face. And finally, sort of wanted to demystify security and compliance because there's a certain amount of myths around it, and I'd like to just sort of demystify that for everybody. So as developers, we're very familiar with this. Our main role, so to speak, day-to-day activities is really debugging, right? We are solving problems, and there's constantly problems to be tackled. And there was this saying that I heard, which is very funny and very accurate, where debugging is like being the detective in a crime movie, where you're also the murderer. This has happened to me as well, right? When I started off, I did not know much about this. As my experience grew, I started to see that I myself was committing a lot of these mistakes that came back to haunt me as a software developer. So I'm hoping to capture some of those lessons and then show you how that ties back to security, how simple things can sort of lead to security issues. So just to recap on what we've seen in the last 2 decades. So when I started my career, there was no real DevOps role. There was infrastructure roles, roles that sort of focused very much, sysadmin typically, who focused on infrastructure and scaling hardware for you. And this typically happened in data centers. And then what happened was the whole cloud revolution happened. AWS came about. You could set up your hardware in just a few clicks. And what that initially meant was, developers could then focus on their development activities, didn't have to worry too much about hardware and scaling hardware. And then DevOps sort of came about because you sort of had to bridge that gap. And then sort of your pipeline became developers responsible for building. Then there was a deployment phase, and then you went into production. So as DevOps happened, developers were able to release software a lot quicker than they normally could. But this obviously meant security was sort of lagging behind because the rate of deployment sort of went up very quickly. So over the last few years, what we've seen is developers are becoming more and more responsible for security, because the sooner you can bake in security as a company into the development lifecycle, the quicker you can catch these security risks, and overall security can be improved. So what used to be traditionally a separated role, developers are today seeing more and more of that being thrown back at them. And this is a good thing, right? Because this is exactly what happened with the whole infrastructure as code. And we are now seeing this with compliance and security. And this is going, they call it the shift left security, which effectively means security is moving closer to your development lifecycle inside your CI/CD pipelines. And that's for a very specific reasons. The number of vulnerabilities have increased. Today you constantly hear this, right? There was Log4j that happened. So your software supply chain as such, the risks have increased tremendously. And DevSecOps now is, it took a while for this to catch on, but I think this term is now quite popular. It effectively means, to DevOps, you've added security now. So not only are developers doing, DevOps, but also security on top of that. But there's plenty of tooling available today. So it's not, you're not completely on your own in that respect. So I want to throw out a very controversial question. I think everybody thinks about this. Can we really have software that is 100% secure? And actually, the answer is yes, but it is extremely costly to get to that phase. So in a practical sense, it's really not possible, right? You have to constantly evolve your software to become more and more secure. And the catch-22 is that as you're adding more of that, you tend to become less secure. So it's a constant cat and mouse game to catch up with any vulnerabilities that might have opened up. And there's multiple reasons for this. So there's inherent complexity today. So there's a lot of tooling, there's a lot of frameworks, a lot of choice as a developer, but that has introduced a lot of complexity. What do you choose? How do these components interact with each other? Who's actually building it? Open source is very popular. Are these third-party libraries being maintained well? Are they keeping up to date with security? As a developer, when you start off, you don't have the security experience. You're also battling, constantly changing requirements, which are sometimes incomplete as a fast-moving startup. And this is very natural again, that's why it's a startup. And of course, unlike bigger companies, startups cannot really prioritize security too much unless they absolutely have to. And that sort of, brings it to a place where you try to do security only as needed. And that's perfectly okay as well, because that's the evolution of software. We've seen that software has eaten the world. And now, of course, every company has realized that they need to focus on security, make that a top priority. So now just sort of moving into some security basics that everybody should know. Some of you would be quite familiar with these things, but as a way of sort of just introducing to these concepts. Information security is sort of dictated by the CIA triad. Has nothing to do with the US agency. They also sometimes call it AIC triad, just to sort of take that CIA reference away. But that's effectively confidentiality, integrity, availability. And what this means is to protect your information, you need these three pillars sort of laid out. And most information security policies are sort of centered around these three pillars. So confidentiality is very simply protecting the data. So you have some important data, typically customers' data. You don't want it out there. So you need to protect access to it. You probably want to encrypt it because, even if it was stolen, nobody has the keys to figure out what is inside there. So confidentiality is predominantly access control and encryption. Integrity, you want to be sure that the data that was transferred to you is actually what it is. And once you store it, it is what was originally stored. So that's typically signatures, hashing, and those sort of primitives to sort of make sure the data is what it was. And finally, availability. If your data is not accessible, it's as good as not having any kind of service or product. So availability is extremely important. So how do you safeguard your data against data losses, disasters, and also attacks, of course. So this includes things like resiliency. How is your system resilient to sort of making sure the data you've collected simply cannot be lost? And then cryptography is a key component of security. So there's various ways to achieve cryptography, typically encryption. The most common method is a secret key. You have a secret key, which you keep secret, and you use that to encrypt your data. And then you store what is called a ciphertext. Public key is effectively a public and private key combination, where you keep the private key a secret and you encrypt it with that. But then so there's a two-layered encryption there, private and public key. But then you can give out your public key, which can then be used to decrypt your data that was encrypted with your private key. And that's typically how, for example, TLS or SSL works. That's encryption in transit, effectively, between the browser and the server. And hashes, this is typically a one-way function where you don't necessarily need to go back to what is, you cannot recover data from a hash. It's very difficult. So you don't necessarily need to get access to the original data, but you probably want to compare that with data that's coming in without actually storing that data as is in your system. So hashes achieve that. You've got, let's say, for example, a password is a classic example. You don't want to store password in plain text ever. So you hash it. And then when you're comparing a login from a user, you take their entered password, hash it, and then compare the hashes. Principle of least privilege, it's the idea is that in terms of access control and sort of the permissions around it, you want to give the least possible permissions or privileges to people around data and systems. So as an example, you don't want everyone to access your production systems. You want to heavily guard that only administrators or sort of your senior engineers need access to the full system. And then you want to safeguard access control depending on the different roles within your organization. And finally, as a developer, you definitely need to know the OWASP top 10 vulnerabilities. So OWASP is an organization that sort of captures predominantly web vulnerabilities, and extremely important to sort of be on top of what these are and how you want to safeguard your application against it. So every year or every 2-3 years, there's constantly changing this list. They're looking at all the vulnerabilities that happen and which ones are sort of most susceptible for you as a company, and predominantly focused on web applications, which is what we are all typically building today. So one big piece of advice that you'll constantly hear as well, and it sometimes is a bit ambiguous, is you do not roll out your own cryptography. And what this effectively means is go with best practices, industry standards in terms of encryption, decryption, and those sort of things, because it might be fun to sort of try a few things, but it's very easily broken if there's not enough research put behind it. So you always want to sort of follow what the community does. There's a lot of security researchers doing this for us today. They're looking at various protocols and standards and when that breaks and what's coming up next. So you'd rather just follow that and not try to bake in your own cryptographic techniques. You want to do it for fun, for learning, but never in production. So just keep that away from production. And go with for example, if you're doing encryption, you want to go with your standard AES 256-bit encryption, because that's known to resist most attacks that are possible today. And of course, that might change, but you will have enough lead time to sort of make changes to move on to the next protocol. Passwords, I think this is a classic example. Even the biggest companies in the world have done this, and I think they still continue to do it, which is not very nice. Which is storing plain text passwords. So you enter your password, it gets stored directly in the database. That's just a bad idea, because you never want to reveal a password to anybody, not even an admin, right, in a company. So the most common technique, of course, that should be followed is it should be hashed. You never want to encrypt passwords either, because while it sounds like an interesting thing to do, if your encryption key is leaked, so is your password. So hashes is the best way, because you can never come back to the actual password. Of course, you don't want to use fast hashes, because the idea is to prevent password attacks. So the slower the hash, the better, which basically means that it becomes impossible to do brute force attacks on your system, and basically guess passwords. You want to use a salt, because the same password for different users should not end up with the same hash. That's a security vulnerability as well, because then they could use the other one to log in as another user. So you want to use something called a salt, which is effectively a random character set that gets added to the password when you hash it. And the beauty about hashes is a small change in the original text, and the hash is completely different. So that's why the salt is added, so that it gives it a bit of variation, and you end up with a different hash altogether. So the beauty of hashes is that it's one way. So you cannot get back the original text from a hash. So even if you were attacked and lost your data, nobody can actually get back to the original password. And that's why that's why you want to always hash it and never encrypt a password. And you also want to use a salt. This is extremely important, because if multiple users have the same password, you don't want to end up with the same hash, because that opens up possibility for a security attack. You could impersonate another user if you knew that this is happening. So you want to use a salt, which is effectively just a random cryptographically safe string that gets attached to your original password. And the great thing about hashes then is that if the original string changes, then so does the hash. So even for small variations in the original string, the hash is completely different. So that's why salting is extremely important and is a must-do. And OWASP recommends these 4 hashing algorithms, and you're better off sticking to those, predominantly because they are the right set of hashes for use with the password. The slow, you can have multiple rounds of hashing, so you can slow it down even further. And they're essentially cryptographically secure. So bcrypt is the most common hashing technique for passwords. You should use that where you can. The other ones are scrypt. Argon 2 is quite a new one. It's becoming very popular. And PBK DF2 is a very specific one. If you need something that's called a FIPS 140 specification from the US government, this is typically if you're selling into US government, then you definitely need to do a PBK DF2. So it's not very common. It's for very specific purposes. So bcrypt is usually the way to go about passwords. The other very common vector for attacks on a web application is input fields. So every application has that, extremely important. If you do not validate the input, if you do not sanitize the inputs, then that opens up a whole range of injection attacks, all the way from databases, SQL, down to cross-site scripting on your web application itself, where attackers could potentially run their own scripts on your web application and steal data on the back of that. And in a very similar way, whatever you return from your server, your output, for API requests, for web pages or whatever this could be, should be encoded in the right format as well. Because if you don't encode it, you're effectively opening up, because the browser will effectively execute something that could be a script. So you want to encode your output so that the browser then cannot execute it in any form. And if you do these two things, you close off a whole range of injection attacks that are predominantly the way to sort of for attackers to get into your web application. Character encoding, extremely tricky topic. I think even the best developers stumble on this at times, because it's extremely tricky. If you're dealing with the ASCII set, very easy. There's no nuances, no edge cases. But as soon as you get into Unicode, then there's a whole range of attack vectors that open up. So a simple example is, you're probably doing uppercase, lowercase comparisons, and that's very standard, right? Every application has that. But there's actually character set collisions within the Unicode character set, which you may not be obviously aware of. A classic example is if you take the German character, it sort of, when you lowercase it, it becomes a double S. And what that effectively means is if you're comparing two strings, comparing the lowercase of them, you could have collisions, and that has huge impact on effectively around emails, because emails are the way to sort of uniquely identify accounts in any system. So we'll take this example of email normalization. Most companies take an email, normalize it in some form, either uppercase or lowercase it, and store that in the database. And then when the user logs in, their email is again, either lowercase or uppercase, and compared with what they have in their database. And this is a big problem, because if someone identified a character set that can collide with an existing email on your system, they could use that to get into your system. And this has actually happened with GitHub, where a security researcher found a vulnerability. I think it was the Turkish I, which looks like an I, but is not an I, but the two of them collide, I think when you lowercase it. So what happened was you could use an email from another domain, go to your password reset UI, and then use that email to reset the password. And then it ended up sending the email to the new email that you entered, which is actually a collision with the other one, because GitHub, of course, thinks that they're the same account, when in reality it isn't. So you can see that, very sort of these edge cases that very hard to think about, very hard to know about, can cause these sorts of attacks. Of course, the probability is quite low, because you need to have that exact collision with an existing email on your system. But if you're a very popular system, this is quite normal and natural, like with GitHub. And of course, these typically lead to account takeover attacks. Then, of course, password reset in a similar fashion as I described earlier. There's a few things you need to do when resetting password, which otherwise simply opens up a vulnerability where you could end up sending that, because the reset password ends up sending a URL to change your password. And if you end up sending it to the wrong email, you're essentially giving access to your user's account to somebody else. So that that character set collision results in account takeovers. So a simple way to avoid most problems with password reset is always send the password reset request to the email that you have on your system, and never to the one that the user entered or the one you normalized. Because at least that then ensures no matter what happens on this side, only your original user is getting the email, and he can then he can then know that it wasn't him that requested it, and you can sort of will report back to you. because if you do end up sending it to the wrong email, you've effectively given up ownership of that account. Because they can come and reset the password, take over the account, change emails, and do other things that then sort of completely takes over the account. So that's one single thing you can do well with password reset is always use the email on your system, never anything else. Another classic one that I've also sort of in the past been bitten by is managing secrets. I should throw that in the source code, right? Easiest place to drop it in. You hard code it somewhere, and then you quickly realize that staging is using the same secret, production is using the same secret, and all your alpha environments are using the same secret. So just don't do that. Try and keep that away. Use environment variables and pass it in the right way. Because the other problem is if source code does leak in some form, then your secrets go with it. So you effectively expose your entire system on the back of that. And this actually happened in our team once. One of the engineers accidentally published an NPM package, which was meant to be private, but he ended up publishing it because he thought he was publishing another library. And that had certificates and all of these sort of things in the source code. So we effectively ended up having to test our disaster recovery scenario, recycle all the certificates. They were used for JWTs, so we then had to recycle all our JWT tokens. And it just ended up being quite messy at the end of the day. Good test of our disaster recovery process, but not recommended. And along the same lines, you're constantly logging, you're writing to console, so you don't want to accidentally leak secrets in there. So do watch out for what you're logging, and wherever possible, try and use a masker on top of your logger. Plenty of libraries available which will try and detect the patterns of these secrets and then try to mask it if you accidentally put it into your logs. As I mentioned earlier, use environment variables for your secrets. And the best thing to do here is use something like HashiCorp Vault or one of the cloud services to manage your secrets. Extremely useful, actually not just in production, but for your other environments as well, because you can segregate them, you can keep it isolated, and you can cycle them very quickly if something were to happen. Logging, as I mentioned, PII leakage in logs, definitely watch out for that. And the most important thing, as we saw with Log4j, don't allow any kind of code execution in logs, because that opens up a whole bunch of vulnerability attacks, like we saw with Log4j. So the best thing to do there is, treat logs as just string and then, nothing else. Handling sensitive data, very important. PII data, you want to firstly store only what you need. So if there's something you're collecting from your customer that you don't really need, you're better off just not collecting it and storing it. Encrypt it at rest. You definitely want to use some kind of encryption algorithm. AES 128 AES 256 is highly recommended. Encrypt it at rest, keep the secret away from your system. That way, if you're ever hacked, you're just leaking ciphertext data, and there's not much a hacker can do with it. You want to use TLS for transport so that it's encrypted end-to-end. There's no risk of a man-in-the-middle attack. And you absolutely want to lay out good and strict access control around the sensitive data, making sure that only people who really need access to it are given access to it. Third-party libraries, we're all aware, open source. We're using more and more of that these days. You want to check for outdated, unmaintained libraries. You want to check for vulnerabilities on them. You want to automate these things in CI/CD and not, have to worry about it manually. Plenty of tooling available around this today. So, utilize that, bake it into your CI/CD pipelines. But most importantly, you want to have tests so that if you're updating libraries, you can be certain that you don't break your system. And this is quite important because it's a catch-22. What happens is, I've done this in the past as well, right? I've used a library, I just don't want to update it because it comes with so much headache. The APIs might have changed. I don't know where exactly it's used. So if you have good tests around this, then you can update the library, let CI/CD run the tests, and you're fairly certain that it doesn't break anything. And you're also then up to date with in terms of security. So testing that way goes hand in hand with security. The more tests you have, you don't need to have 100%, of course, that's always hard, but you want to have enough for the critical bits so that you can keep your libraries updated, you can keep your systems updated, operating systems, so that one, of course, you're up to date, and two, you're not actually breaking your system on the back of these updates. And finally, be secure by default. This is very interesting. It kind of is a bit of psychology as well. Your design choices dictate the security of your system ultimately. So I'll give you an example of how this works. So MongoDB, when in the initial days, as they were getting popular, for ease, they turned off authentication by default. So what this meant was, they wanted to make it easier for developers to try MongoDB, make sure it works, not have to worry about authentication to the database itself. And the second thing they had was they connected to the address 000 when the MongoDB started, and 0000 means connect to a public interface as well. So what happened was developers who traditionally not used to infrastructure and DevOps ended up hosting these MongoDB instances, which then was basically open to the public. And it's a well-known port, 27017. So you had lots of bots going out there and looking for this port. As soon as they saw an open port, they basically downloaded all the data, deleted it, and started asking for a ransom around this. So they suspect that about 28,000 plus databases were exposed this way. And of course, later version MongoDB patched that up and had authentication on by default. But you can see that a design choice that they made affected security as a whole, because whatever is by default, you should assume that developers will end up using that by default and not really change that. So in a similar fashion, when you give your documentation examples, try not to include anything in there that's actually kind of real, because you will end up developers copy pasting it and then just leaving it there, which effectively means a security key used in your doc will end up being the security key for a lot of production systems out there, which is invariably a security hole. And in the same way, default username passwords, again, very risky. So like the routers normally have, if you do that on your server, for instance, you're invariably going to get attacked. I wanted to talk a little bit about compliance and regulations, because they inherently are tied with security quite closely. The reality is that a lot of companies would not take security seriously if the compliance and regulatory frameworks on top were not sort of mandating it. So what they are effectively is a set of guidelines, best practices. There's whole research bodies around this that are responsible for these compliance and regulatory frameworks. And the intention is very simple, right? They want to make sure companies that have sort of taken a lot of data under their wings are doing the best things to sort of protect that data. And that's what it is really about, right? Because as we saw, 100% security is always utopia. So by doing this, they're ensuring that companies can stay on top of security. And it's an ongoing process. It effectively never ends. Just because you have a certification or a regulation done, it doesn't mean it's actually done. Your entire company is sort of continuously sort of ensuring that it's maintained over time. Very much like software is, right? Software is never done, neither is security around software. And it's not just the engineering team that is responsible for this, including your compliance and regulatory frameworks. The entire company is typically involved. It cuts across various departments because, if you think about sales, marketing, they're dealing with sensitive data as well. So they need to be aware of the same set of things that engineers are aware of. And this typically also involves a lot of training. So companies will roll out training specifically for departments and also generic ones across the company. So some classic examples are ISO 27001, SOC 2. These two are very popular with B2B companies. At some point in their journey, they need to get compliant with one or both of these compliance frameworks. GDPR, everybody's aware now. You have to safeguard your customers' data. And it's no longer just a European thing either, right? It started there, but now pretty much worldwide, there's been various data regulations that are modeled around GDPR and modified to suit the local market. And then there's vertical specific regulatory frameworks as well. Example is PCI in the finance industry. If you're dealing with payment cards, you have to be PCI compliant. And HIPAA, which is for healthcare startups that are dealing with health-related data. Extremely important to safeguard that because there's a whole lot of privacy issues around leaking, health information of your patients. So that's sort of where security blends with these. You've got compliance and regulatory frameworks dictating it at the top, and then companies implementing the security guidelines underneath this. So some final notes around what we just spoke about. So the idea was to give everyone a sense of what security entails. As you can see, it's quite vast. It was impossible for me to cover a lot of topics there that I'd love to have. But hopefully, the talk has sort of inspires you to think about security a lot more as you go on about your day-to-day operations. But if you think about it, security really, at the end of the day, is about risk management, and that is how companies deal with it. That is how compliance frameworks are built as well. It's not something you can set and forget. You essentially have to set it and then maintain it and tweak it and iterate on it. And risk management is effectively essentially these things, right? You look at the probability of this attack happening or vulnerability. Or something that your company or product is exposed to, and you weigh it against the severity of this. So if that happens or if that comes true, what is the impact on your company, on your business? And then once you weigh those two, it helps you prioritize which ones to look at first and which ones you can actually ignore as well. Because if something is very low probability and very low severity, it's probably okay for the time being to not worry about it. So that's how companies model their information security and compliance processes around this. And effectively, compliance is a way to reflect your company's security process, because technically no one can come in and do a full audit of all your systems. They can take slices, they can broadly look into what you're doing, and that's what these compliance frameworks cover. So you're effectively saying, I take security seriously. This is the process I've laid out, and this is how I'm trying to mitigate all the risk associated with my company and product. So lastly, for us developers, what we need to do is, there's a lot of complexity out there, which is perfectly fine. Try and keep it simple. You want to use it as a ladder or a step process where you want to only lay out as much as is needed for your company for the next stage, and then sort of build on top of that, right? So you want to start small and then sort of expand on it. So the best thing you can do is make sure you sort of take up security reviews along with your code reviews. That's a very good place to start. And then from there, you sort of expand out and start to lay it out in the rest of your development process. Could be CI/CD, could be deployment, and then of course cross-department collaboration over time as well. And there's a final slide with some useful resources, which are extremely good to, you know, just get started around this. OWASP and SNCC has a lot of documentation around this, very good cheat sheets where they cover, you know, every aspect of security and what you can do around that. Auth0 has some very good coverage of the common vulnerabilities around it as well. And some very good examples of, you know, real life vulnerabilities that have been documented. And of course, you know, where possible, try and use a you know, a good open source, well-maintained library around authentication, authorization, because that then, you know, offloads all of your security responsibilities, because, you know, they take care of it for you. But barring that, of course, you know, you want to make sure you are covered as well with the things that you do. And thank you very much. I hope you enjoyed the talk, and I'm around for any questions that may come up.